Our celestial companion, a glimpse at the moon. Look up at the night sky. What do you see? Stars, of course, scattered like diamonds on black velvet. But there's something else, a constant companion in our celestial journey, the moon. This silvery orb with its ever-changing phases has captivated humanity for millennia. But have you ever wondered where the moon came from and how it has shaped our world? The moon's story is a dramatic one, a tale of cosmic collisions and celestial choreography. It's a story deeply intertwined with our own, for the moon is more than just a pretty face in the night sky. It is a celestial guardian, a silent influencer that has shaped the destiny of our planet. In the beginning, the Big Bang and the birth of the universe. To understand the moon's origins, we must journey back to the very beginning, to a time when the universe itself was born. This journey takes us to the moment of the Big Bang, a pivotal event that set everything into motion. Roughly 13.8 billion years ago, there was nothing but a point of unimaginable density and heat. This singularity contained all the mass and energy that would eventually form everything we see around us today. Then, in a cataclysmic event we call the Big Bang, everything exploded outward. This explosion wasn't just an explosion of matter, but of space itself, creating the very fabric of our universe. Space itself expanded, and the universe as we know it began. This expansion was rapid and immense, stretching the universe to vast proportions in a fraction of a second. In the fiery aftermath of the Big Bang, the universe was a chaotic soup of elementary particles. These particles were in constant motion, colliding and interacting in a hot, dense environment. As the universe cooled, these particles began to combine, forming the first atoms of hydrogen and helium. This cooling process took hundreds of thousands of years, but it was crucial for the formation of matter as we know it. These simple elements would become the building blocks for everything else in the cosmos, from stars to planets to you and me. Over billions of years, these atoms clumped together under the force of gravity, forming stars, galaxies, and eventually, the complex structures that make up our universe today. From dust to planets, the formation of Earth and its neighbors. The story of our planet and its celestial neighbors begins in the vastness of space, within immense clouds of gas and dust. Over eons, gravity drew together vast clouds of hydrogen and helium. These clouds, known as nebulae, were the birthplaces of stars and planets. The gravitational forces at play were immense, pulling the gas and dust into tighter and tighter clumps. These clouds collapsed under their own weight, igniting as stars. The process of star formation is both violent and beautiful, as the gas heats up and begins nuclear fusion, creating a new star. This is how our sun and countless other stars came into existence. The intense heat and pressure within these stellar furnaces forged heavier elements like carbon, oxygen, and iron, the very elements that make up our planet and ourselves. These elements are essential for life as we know it, and they were created in the hearts of stars. When these massive stars died, they exploded as supernovae, scattering these newly formed elements across the cosmos. These explosions were incredibly powerful, sending shockwaves through space and distributing the building blocks of planets and life. From these stellar ashes, new generations of stars and planetary systems would arise, including our own solar system. The remnants of these explosions coalesced to form new stars and planets, continuing the cycle of creation and destruction. Roughly 4.6 billion years ago, a swirling disk of gas and dust, a nebula, coalesced to form our sun and the planets that orbit it, including a young, molten Earth. This was the beginning of our solar system, a dynamic and ever-changing collection of celestial bodies. A titanic clash, the birth of the moon. The early solar system was a chaotic place, a cosmic shooting gallery where collisions were commonplace. Planetesimals, the building blocks of planets, smashed into each other, some merging to form larger bodies, others being blasted apart. It was during this tumultuous period that the moon was born. Imagine a young Earth, still a molten ball of rock and magma, when a Mars-sized object, which we call Theia, slammed into it with unimaginable force. The energy released in this colossal impact was beyond anything we can fathom. Debris from both Earth and Theia was blasted into space, forming a ring of molten rock and dust around our planet. Over time, this debris, bound by gravity, coalesced to form the moon. This cataclysmic birth explains why the moon's composition is so similar to Earth's. It was literally formed from a piece of our own planet. While other theories about the moon's formation have been proposed, the giant impact hypothesis, as it is known, is the most widely accepted explanation today. Some scientists have suggested alternative scenarios. Perhaps the moon was a wandering body captured by Earth's gravity, or maybe it formed alongside Earth from the same primordial cloud of gas and dust. But these theories struggle to explain the moon's unique composition and its almost perfectly circular orbit. The giant impact hypothesis, while dramatic, offers the most compelling explanation for the moon's existence. The impact that created the moon had a profound impact on the young Earth. The energy released melted the planet's surface, creating a global magma ocean. The atmosphere was blasted away, leaving the planet exposed to the harsh radiation of space. It was a time of intense heat, volcanic eruptions, and constant bombardment from asteroids and comets. But amidst this chaos, the seeds of life were being sown. Meteorites, drawn in by Earth's gravity, rained down on the planet's surface. These celestial messengers carried within them not just destruction but also the building blocks of life: water, carbon-based molecules, and even amino acids. As the early bombardment subsided, the Earth began to cool. The magma ocean solidified, forming the planet's first crust. Water vapor released from volcanic eruptions condensed in the atmosphere, falling as torrential rains that filled the first oceans. The Earth was transforming from a fiery inferno into a world more hospitable to life. The presence of liquid water, a stable atmosphere, and a more moderate climate paved the way for the first single-celled organisms to emerge in the primordial oceans. Life, once just a possibility, had taken hold on our planet. The moon, our celestial companion, played a crucial role in shaping the environment that allowed life to flourish. Its gravitational pull creates the tides, the rhythmic rise and fall of ocean levels that we observe today. But in Earth's early history, the tides were even more dramatic. The moon was closer then, and its gravitational pull was stronger. These powerful tides, combined with the Earth's rotation, created a dynamic environment along the coastlines. The constant ebb and flow of water churned up nutrients and created shallow pools where early life could thrive. The tides, driven by the moon's invisible hand, acted as a cradle for the evolution of life in Earth's oceans. The moon's influence extends far beyond the tides. It is a celestial body that has been a constant companion to Earth, shaping its environment and life in profound ways. It acts as a stabilizer for Earth's rotation, preventing drastic shifts in our planet's tilt that could have led to extreme climate fluctuations. Without the moon, Earth's axial tilt could vary wildly, causing severe changes in seasons and climate, making it difficult for life to thrive. This stability has been crucial for the development and evolution of life on Earth. The consistent climate allowed ecosystems to flourish, providing a stable environment for plants and animals to evolve over millions of years. The moon's gentle light has illuminated the night sky for billions of years, influencing the behavior and evolution of countless organisms. Nocturnal animals in particular have adapted to the moon's phases, using its light to navigate and hunt. Its cycles have provided a natural rhythm to life on Earth, guiding everything from the migration of animals to the growth of plants. Farmers have long used the moon's phases to determine the best times for planting and harvesting crops. From its fiery birth to its enduring presence in our skies, the moon has shaped our planet and our lives in countless ways. Its formation, likely from a colossal impact, set the stage for the unique conditions we experience on Earth today. It is a silent guardian, a celestial companion, and a constant reminder of the interconnectedness of all things in the vastness of space. The moon's presence is a testament to the delicate balance that sustains life on our planet, a balance that has been maintained for billions of years.